Now let's discuss a little bit more about reactions of cations in qualitative analysis. So if we look at this table, which will be given in the exam, so you do not need to try to memorize anything from this table. So usually, okay, to test the presence of cations, we are going to use two reagents. They are aqueous sodium hydroxide and aqueous ammonia. If a question asks you to suggest, okay, or to select reagents to test the presence of cations, okay, always write NaOH in bracket AQ, NH3 ammonia in bracket AQ. Now this aqueous state symbol in the bracket is very important because if you don't specify the state, sodium hydroxide is actually a solid at room temperature, okay, room pressure. Ammonia is actually a gas. So to test the presence of these cations, we need aqueous solutions of these two chemicals, right? Now, by testing with sodium hydroxide and ammonia, you're going to see whether a precipitate is formed or not. So first, you're going to add a few drops of sodium hydroxide, okay, or ammonia aqueous solutions into normally 1 cm depth of the unknown solution that you test, and you observe whether there's precipitate or not. Now, whenever you want to do, you want to test a solution, and if precipitate is going to form, please add very minimum amount of the reagent to make sure that you have a minimum amount of precipitate form. And when you add sodium hydroxide solution or ammonia solution in excess, it is easier to see whether the precipitate is soluble in the excess solution or not. If there is too much of precipitate that's being formed, even if you have you have a precipitate which is supposed to be soluble in excess solution, might not be able to fully dissolve in the solution, and that will give you a false observation. So make sure you only add a few drops, okay? I'll usually just add 1 to 2 drops of sodium hydroxide and aqueous ammonia to observe whether there is precipitate or not. And I'll add the solution until it is in excess, okay? Minimum, okay, in excess means minimum double the volume of the initial solution. Best is if you can add more and use glass rod to stir to check whether the precipitate is soluble in excess solution or not. Okay, so I'm going to show you a few more less, not to say less common, I'll rather say that it's more unique type of observation. For example, like manganese. Manganese 2 cation is supposed to form off-white precipitate with sodium hydroxide solution and aqueous ammonia solution. And then this off-white precipitate will quickly turn brown, okay, or when you just leave it to be exposed to air. Now let's go to the next one to show you what type of white precipitate that you might see during the exam. So most of them, if you look at the picture in the middle, most of them it will form an off-white precipitate like this. Okay, looks a bit ivory, looks a bit beige color. Okay, if you're not sure whether this is off-white precipitate or not, what can you do is you can just leave it stand, okay, for as long as possible. You can do other tests, you conduct other tests first, then when you come back to it, you realize that, oh, the upper part has turned darker brown, okay. The one that is not so exposed to the air, the one that's in the solution, they turn dark slower compared to the one on contact with air. So then you can confirm, okay, this is off-white. It was off-white precipitate and turns brown, okay, on contact with air. And if you're so unsure of how to write this observation, okay, what can you do is you copy this observation into your observation column, right? For manganese 2, off-white precipitate, rapidly turning brown on contact with air, and okay, the precipitate is insoluble in excess. Okay, same observation for both sodium hydroxide and ammonia solution test. Okay, now another precipitate that will turn brown on contact with air will be the reaction between iron 2 with sodium hydroxide or with ammonia solution. So it will turn green. Okay, green precipitate will form. And again, right, if you are unsure that it is iron 2 green precipitate, right, or chromium 3 green precipitate, you're unsure which ions is in the solution, you can again leave the green precipitate to be exposed to air for a while. Okay, at the same time, you can run other tests. When you come back to it, if okay, the part on the surface that is exposed to air turn brown, okay, and this green precipitate was because of iron 2. Now for chromium 3, okay, the precipitate will not be oxidized, so it will stay gray-green, even if you just leave it to stand for a while. Unlike iron 2, iron 2 hydroxide is formed, the part that turned brown was because iron 2 hydroxide is oxidized to iron 3 hydroxide, and the color of iron 3 hydroxide is a brown color solid. That's why the upper part that is exposed to air, it turn brown. Right, so I show you another picture. Okay, also green precipitate, iron 2 hydroxide, and the upper part has turned brown because it was on contact with air. It was oxidized to iron 3. So next I'm going to talk about how do you write the observation. So if this is before an unknown solution, before added any reagent, okay, you start with a colorless solution. Now these bubbles are because there's a glass rod stirring the solution. It's actually a colorless solution. Now after adding a reagent, for example sodium hydroxide, let's say the solution turns cloudy like this. Okay, so the observation that you should write will be white precipitate form. Okay, or just white PPT. Okay, for this one. Now, if before and after you see no change, no precipitate, solution remains colorless, then you should write no change. Okay, or you can write no reaction. Okay, do not write dash. Okay, this one is not acceptable. Okay, a dash in your observation column means you didn't attempt the test. So please do not write this. Only no change or no reaction. Another example of no change and no reaction. Okay, I'm going to show you a series of photos when to show you that when do you need to write white precipitate. Okay? If you see something, observe something like this after added a reagent to an unknown solution, you should write white precipitate, okay, for the observation. Okay, again, white precipitate. So as long as the solution is not clear, okay, and you see some solid dispersed, okay, floating in on the solution, okay, dispersed in the solution, okay, write down precipitate, and in front of the precipitate will be the color of the precipitate. So it should be white precipitate. Okay, white precipitate again. Okay, white precipitate, white precipitate. Now this is also white precipitate. I'm gonna be like, okay, this part has some solid, white solid, but this is clear. Now, this is because, okay, the reagents are only reacting with the upper part of the solution. Test tube, given that the test tube is so long, my reagents are only added to the upper part, from the upper part, okay, drop to the upper part and react with the upper part first, and this part has not reacted with the reagent. So what can you do is, okay, use a glass rod, stir the solution to make sure that solution is uh, uniform, okay, then the whole solution will turn cloudy. And again, you should write white precipitate for your observation. Now this is a colorless solution. Clear, okay, no precipitate, this is a colorless solution. White precipitate again, white precipitate, white precipitate, okay. White precipitate, can you see that, the light cannot go through, it's not clear, okay. And you have white solid at the bottom, sink to the bottom, and here you have very fine white solid particles dispersed in the solution. So this is also white precipitate. White precipitate, okay, this is very obviously white precipitate. White precipitate again, okay. Now, on the right will be white precipitate. On the left, okay, you can see that it is clearly more yellowish compared to the one on the right hand side. Okay, so this one can be pale yellow precipitate or a cream precipitate. Okay. White precipitate, white precipitate, white precipitate. Now this is a yellow precipitate. Both white precipitates. Okay, another white precipitate. Okay, white precipitate again. This is also white precipitate because you can see that the white solid actually uh, sink to the bottom of the tube. White precipitate. So if you see something like this, please do not write two layers. Okay, this is not two layers of anything. It is just precipitate sinking to the bottom. And the previous one that I showed you, okay, this one, okay. If you see something like this, please make sure to use the glass rod to stir the solution. Okay. If you have stirred the solution and they split to two layers again, then you can confirm that, okay, you have two layers of solution, right? Clearly split from each other because they are immiscible. But after you stir and you get a uniform solution that looks like this, then your observation should be white precipitate.